I also had a request to work through the buffer questions from recitation this week. Definitely good practice to work through the buffer questions. I tried to set up a table. It was a little bit different than before, but we have two different ways to kind of visualize what's happening with the buffer and what's happening with our concentrations. And so we can start off with the information we have. We've got 0.65 of our conjugate base. So we can put 0.65 there. We've got 0.455 of our acid. And then to that, I add 0.089 of my base. And we can do the same thing over here. Say I've got 0.455 of my acid and 0.65 of the conjugate base. We add a strong base to that, right? Basic instinct should tell you if you're adding a base to solution, the concentration of the conjugate base should go up. The pH should also go up, and the concentration of my acid should go down. The strong base should react with the acid. So we react the base here. We're going to subtract that concentration here. The product of that reaction is more conjugate base. So we want to add the concentration here. Remember, both concentrations need to change. I think I confused some of you by including the hydroxide here, but the key that I wanted you to pick up from this was that all of the hydroxide reacts. That's the key to the buffer. All of the strong base or strong acid that you add reacts. So we can find our new ending concentrations. I get 0.366 of the acetic acid and 0.739 of the acetate. Right, we could redraw these if you need to redraw the new ones, right? This should be a higher concentration. This should be a lower concentration, right? So A minus became 0.739 and my acetic acid became 0.366. The last step to find the pH, we need Henderson-Hasselbalch. pH equals pKa plus the log of my base concentration over my acid concentration. So pH equals, remember, pKa is the negative log of Ka, so negative log of 1.8 times 10 to the minus 5, plus the log of my base concentration, 0.739, over my acid concentration, 0.366. I should get a pH of this solution of like 5.05. As with any question you see from me, we should be prepared to do multiple versions of it or different directions of it. And so here's an example of that. We've got the same buffer. We're starting off with the same initial concentrations of my acid, my conjugate base rather, and my acid. And to this, instead of adding a base this time, we're going to add a strong acid to this. And so the big difference here, we're adding a strong acid. I should expect to see the concentration of my acid go up. I should expect to see the concentration of the conjugate base go down. So let's fill in everything that we've got here. We know acetic acid is 0.455. My conjugate base 0.650, and my acid is 0.119. And we know it all needs to be consumed at the end of the reaction, and we know, because I'm adding an acid, I'm adding a strong acid, I should see the concentration of my weak acid increase. So I want to add that concentration over here, because the reaction we're seeing, my conjugate base will react with a strong acid to form more of my weak acid. So I subtract here. I get my new concentrations of 0.531, wrong concentration there, 0.574, and 0.531 here. So my conjugate base, that concentration goes down. My acid, that concentration goes up. It ends up actually being a little bit higher than my concentration of my conjugate base. So after the reaction, all the HCl is consumed. We used all the HCl. My conjugate base concentration dropped to 0.531 and my acid concentration went up to 0.574. Calculate the pH now. pH equals pKa plus the log of my base concentration over my acid concentration. Plug in the values we know. Negative log of 1.8 times 10 to the minus 5 plus the log of my base concentration, which is 0.531, and my log of my acid divided by my acid concentration, 0.574. Should get a pH of this solution. It should be lower than the last solution. It should be more acidic than the last solution because we added a strong acid, and it is. I got a pH of 4.71. Again, the biggest mistakes people make when they do these calculations is that they don't change both concentrations. Both concentrations need to change in a buffer calculation. If you're adding an acid, you should expect to see the acid concentration go up at the expense of the conjugate base. That concentration should go down. Important in that both concentrations need to change. One will go up, one will go down. Too often I've seen students just change one concentration and then carry forward with a reaction. So hopefully that helps you prepare for the exam on Tuesday by reviewing a few of these calculations. I've got the review session Sunday night if you've got any questions.